Welcome back to my YouTube channel. Alfred is my name. Please subscribe to my YouTube channel and enjoy technical drawing lessons. The link is below there and my contacts are there as well. We are continuing with the development of surfaces, and this time we are concentrating on cones, as you can see on the screen. And the method of development is radial line method. Now, what you're seeing there is a right cone placed on the horizontal line, as you can see, and with its plan included. Now, what we do here, we first divide the circle into 12 equal parts, as you can see, and after dividing, you label your circle, as you can have it there still, from 0 up to 11. So when you label this circle, you discover that you have created the points for plotting. Now what we do, we project lines from the points on the circle. Like as you can see, we have lines through 0, 1, 2, 3, 4, 5, like that, to the base of the cone. We have those points on the base of the cone, and we are going to label them as we see them from the plan. So 0, we have 0 there, 1 and 11, which is 1 and 11, they're in the same line, 2 and 10, 3 and 9, 4 and 8, 5, 7, and then 6, as you can see them included on the base of the cone. We now join those points to the apex of the cone itself, such that we create the imaginary lines on the front view. Having done that, because the cone is seen as a circle when you view from the top, having created the imaginary lines on the front, you can as well create them on the plan to show the complete view of that figure. Now, how do we put the development? The first thing we do is to draw an arc using apex as the center and stretching the compass to one side of the cone itself, that giving us the slanting edge as the radius for the development. And then we make our arc, as you can rightly see it there. And I've tried to represent here that the radius of that arc is measured from A to 0.6. Now, having done that, we create our small divisions on the curved surface you have created using the small arc radius of the circle, like the distance from here up to that point. It's what you take as a compass radius, and then you start marking those divisions until you obtain the number of divisions equal to the ones you created on the plan. That means you should have 12 divisions. After putting those divisions, we can number them for easy plotting. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, back to 0. Now I'm trying to put the demonstration here that the distance between 1 and 2 is equivalent to the small arc radius on the circle. So what we do, we now join those lines from the apex to those points you have created on your curved surface. Like as you can see here, we have these lines we have joined from the apex to those points. Now, having included those points, we can now outline our figure to give us the required piece or part of development. Now, at this point, we can as well try to include the base of the cone. And when we do that, we shall include here the circle having the same radius as that radius of the base. And the distance from this point up to the center here is measured by the radius of that. And that is how you develop the cone. We can outline our circle and we have it completely drawn. Now, alternatively, you can choose to put that development away from the drawing itself, because sometimes we can run out of space and want to make the development. So we are going to transfer the dimensions from the drawing we have here to the space where we need to draw the development. So we start by drawing an arc. As you can see it here, we draw the arc, and this arc is having the radius of the slanting edge of the cone you have. Having drawn that, you can see I've demonstrated it here. You can see I've demonstrated it here that the radius is equal to r(6). Now we are going to create our divisions. We put the starting point, I've put 0, and we come to our base of the circle here. We take the small arc radius, we start marking off divisions until they reach 12, and we can label them as 0, 1, 2, 3, 4 up to 12, and the small arc radius is equivalent to the arc radius on the plan. Now after that, we also join our lines from now the apex to the point you've created on the curve, and when you outline, you get the development of the cone itself. And that is how we obtain or we make the development of the cone when it's not cut. Please don't forget to subscribe to my YouTube channel. Ena Alfred is my name. The link is below there, and the contacts are there as well. Thank you.